right now, I mean, an autonomous AI agent can negotiate a multi-million-dollar supply contract in literally a fraction of a second.
Oh, absolutely.
Yeah, it can merge production code, handle medical intake, interact directly with your most important clients. But if that bot makes a massive mistake, say, agreeing to a 50% discount you didn't authorize, or, I don't know, introducing a severe security flaw, the company that built the AI model is not liable.
No, not at all.
You are the deployer. And because of that, the insurance companies who underwrite corporate risk are, frankly, absolutely terrified.
It's the ultimate bottleneck in the technology sector right now.
Yeah.
The capability of artificial intelligence is scaling exponentially, but the accountability is basically stuck at zero. And we're hitting a point where that lack of accountability isn't just an engineering problem anymore.
Right, it's a financial one.
Exactly. It is a trillion-dollar economic wall.
So, okay, let's unpack this. Because today's mission is to decode a really fascinating stack of highly technical internal strategy documents.
And engineering specs.
Yes, and what the authors call a wild idea matrix from a company called Theta Driven.
Yeah, and we're exploring a premise here that completely flips the script on the current industry narrative.
Right, so we want you to ask yourself, what if the biggest hurdle in AI right now isn't making the models smarter or more capable?
Right.
What if the real hurdle is simply making them insurable?
Yeah, that's the core of it. The sources we're analyzing today reveal the blueprints for something called an AR.
An Attested Insurability Receipt.
Yes. Theta Driven is arguing that the entire AI industry's approach to safety is just fundamentally flawed. They are proposing we abandon the concept of software-level guardrails entirely.
Which sounds crazy at first.
It does.
Yeah.
But they want to force the verification process straight down to the bare metal, like the actual physical nanosecond physics of the silicon chip itself.
Okay, so to understand why anyone would want to go down to the atomic level of a microchip, we really have to look at the business reality on the ground right now.
The deployer reality.
Yeah, exactly. You have these massive enterprise companies building incredible autonomous agents, and in the demo environments, they look like absolute magic.
And the executives are thrilled.
Thrilled. But then, the bots just sit there, they stall out at the pilot phase, and they literally never make it to production.
The documents refer to this as the problem of the naked deployer.
The naked deployer, yeah. I love that term.
It's very descriptive.
Yeah.
You have enterprise vendors with immense capability, but the moment the AI hallucinates or drifts from its assigned task, the liability falls squarely on the deployer's shoulders.
Right. The company whose logo is on the website takes the hit.
Precisely. Because the base model providers, companies like OpenAI or Anthropic, they have terms of service that explicitly disclaim this liability. They just provide the engine.
So if you put that engine in a car and it drives off a cliff, they are legally insulated.
Yep. They wash their hands of it.
There's an analogy in the text comparing enterprise AI to car insurance before 1996 that really clicked for me.
Oh, the OBD2 Dongle.
Yes. Before 1996, if you wanted to insure a teenage driver, underwriters basically just used guesswork.
Right, demographics, zip codes.
Yeah, they just look at that and cross their fingers. But then Progressive Insurance introduced the OBD2 dongle. You plug it into the car, and suddenly the insurer has hard telemetry.
They know exactly how hard the brakes are hit.
And how fast the car accelerates.
Yeah.
The sources argue that enterprise AI right now is essentially a teenager driving a fleet of semi-trucks, blindfolded, with literally zero telemetry.
And underwriters, the massive carriers like Munich Re or Lloyd's, they cannot price a feeling of safety.
They need hard data.
Exactly. They deal in hard statistics. But there is a regulatory ticking clock forcing this issue, which the sources highlight pretty prominently.
August 2, 2026.
Right. The European Union's AI Act.
Yeah.
Specifically, Article 14 goes into enforcement then. This law legally requires provable human oversight and conformity for high-risk AI systems.
So the deployers are staring down a pretty brutal multiple-choice scenario here.
They really are. Choice A is to pay the regulators fines, which can reach up to 3% of global turnover.
Ouch.
Yeah. Choice B is to pay astronomical punitive insurance premiums because the risk is unquantifiable. Or choice C.
Find a mathematical, hardware-grounded proof of compliance.
Yes.
Yeah.
If we connect this to the bigger picture, the core insight here is that the real market isn't about making AI safe in some philosophical sense.
Right.
The market is about making AI a rateable, priceable asset class for the reinsurance industry.
Okay, I hear that, but I have to push back a little bit here for the sake of argument. Why do we need hardware to do this?
Right, the obvious question.
I mean, we have massive teams of engineers building software guardrails, intent classifiers, constitutional AI.
Right.
If the AI is just a software program, why can't we just write another software program to sit next to it, watch its outputs, and make sure it behaves?
It totally seems like the obvious solution. But the sources deconstruct this entirely using a really fascinating historical analogy from chemistry.
The drug ritonavir. I saw that in the notes, but honestly, it lost me a bit. What does a 1990s HIV drug have to do with AI software?
Okay, so in 1998, ritonavir was a highly successful, life-saving drug, right? Manufactured in a factory in Chicago. But suddenly, batches of the pill started failing dissolution tests.
Meaning they wouldn't dissolve in the body.
Exactly. They stopped working completely. So the chemists panicked, analyzed the pills, and found that the chemical formula was identical. Atom for atom, it was the exact same molecule.
So what went wrong?
It had formed a different crystal lattice. In chemistry, this is called a polymorph. The same atoms arranged in a slightly different physical structure resulted in a completely dead function.
Okay, so the ingredients were correct, but the geometry was wrong.
Yes.
How does that actually translate to a software hallucination, though?
So Theta Driven argues that an AI hallucination is essentially a cache polymorph.
A cache polymorph.
Right. We tend to think of AI models as deterministic, like the code is the code.
Sure, input equals output.
But an AI doesn't execute in a vacuum. It runs in a highly dynamic computer memory environment, or cache. When you prompt an AI, you are moving massive matrices of data through this memory.
Okay.
If the context of the prompt shifts the routing of that calculation even slightly, the exact same software weights can snap into a different structural output.
Wow.
So a hallucination isn't a bug in the code. It's a polymorph that snapped into place because the memory environment shifted.
And the text has this incredible poetic line for it. They say, the river is the prompt.
I love that line.
Me too. Meaning you can't audit an AI's decision after the fact because the very act of prompting the AI irreversibly changes the cache lines in the computer's memory.
Right. If a software monitor tries to audit the AI, it is literally reading a memory cache that the audit itself just altered.
That's wild. You're observing it, so you change it.
Exactly. Which brings in a fundamental mathematical limitation from 1953 called Rice's theorem.
Oh, I remember reading about this.
Yeah, Rice's theorem essentially proves that no software program can perfectly verify the behavior of another software program without sharing its exact failure domain.
Meaning a software guardrail is blind to its own drift.
Exactly. If the AI model can be compromised by a cache polymorph, the software watching it is vulnerable to the exact same phenomenon.
That drastically changes the way you look at AI safety. Because if software is fundamentally incapable of holding a boundary, then some of the biggest fears in tech are just completely misunderstood.
Oh, absolutely. The sources even reframe the classic paperclip maximizer doomsday scenario.
Right, the idea that an AI told to make paperclips will eventually harvest human atoms to make more paperclips.
Yeah, the traditional view is that this is a misalignment of values.
But this document argues it's purely a structural bug.
They make a very compelling case that an ungrounded software system literally cannot hold a terminal goal. It doesn't have a continuous self to anchor any goal to.
Right, it just runs infinite loops of optimization.
Exactly. So a paperclip maximizer isn't a malicious entity trying to destroy us. It is just broken software suffering from a structural inability to recognize a stopping condition.
Okay, so if software guardrails are basically an illusion, and we can't trust the AI to monitor itself, what is the actual mechanism to fix this?
Right.
Like, how does moving to the bare metal solve a cache polymorph?
By taking the verification entirely out of the software layer, the engineering specs detail a piece of technology called the Local PMU, or Performance Monitoring Unit.
Okay.
It is an incredibly fast, lightweight Rust binary that runs directly on the deployer's physical silicon. It monitors the hardware itself.
And it uses something called a fractal identity map, or
Yeah.
MM.
Yes.
The specs describe this as a 12 by 12 grid,
Yeah.
144 cells. And this grid represents the behavioral lane of the AI.
Right.
But I really struggled with this part, honestly. If an AI is doing something highly complex, like diagnosing a rare disease or writing thousands of lines of Python code, how on earth do you map that complexity onto a simple 12 by 12 grid?
It does sound way too reductive at first.
It really does.
But it sounds reductive until you look at how it measures behavior. It's not trying to understand the English words the AI is typing or the specific Python syntax.
So what is it measuring?
It is measuring the mathematical shape of the execution. The verification happens using combinational logic, specifically a SIMHASH XOR gate.
Okay, stop there, because SIMHASH XOR gate is very heavy engineering jargon. What is an XOR gate actually doing in this context?
Fair enough. XOR stands for exclusive OR. It is one of the most basic logic gates in computing.
Okay.
It compares two streams of bits. If the bits match, it outputs a 0. If they are different, it outputs a 1.
Simple enough.
Right. It is the cheapest, most efficient way for a computer to ask, are these two things different? The PMU uses this gate to instantly calculate the distance between what the AI is physically doing in the memory cache and what the 12 by 12 grid says it is allowed to do.
And it does this at just incomprehensible speeds. The spec says it takes 0.54 nanoseconds per gate comparison. To put that in perspective for you listening, light travels about 6 inches in 0.54 nanoseconds.
Which is insane to think about.
Truly.
What's fascinating here is it is executing at the speed of the hardware itself. A full walk of that 144-cell behavioral lattice takes just 155 nanoseconds.
Wow.
That means the entire verification of the AI's action takes less time than a single DRAM cache miss.
That's faster than thought.
It happens instantaneously as a byproduct of the AI simply fetching data from memory. They call this principle reach, IS, verify.
Reach is verify.
Yes. The physical act of the computer finding the data to make a decision is simultaneously the mathematical proof that the decision is within the allowed boundaries.
This reminds me of the analogy they use involving Luca Pacioli in 1494.
Oh, the accounting one.
Yeah. He was the mathematician who codified double-entry bookkeeping. Before Pacioli, merchants just kept a single ledger, just a running list of transactions.
And because it was just one list, it was incredibly easy to make a mistake or commit fraud.
Exactly. Pacioli introduced the second ledger. The books had to balance against an independent record. Theta Driven is arguing that computing up to this point has never had a true double-entry system.
Right. The software is just a single ledger.
And the software can lie to itself. It can hallucinate.
Precisely. This silicon-level PMU is computing's missing second entry. It provides an independent mathematical ledger anchored in the physical hardware, which the software layer literally cannot alter or deceive.
To make this process visible, because you can't exactly hand an insurance underwriter a printout of cash misses, they use a visualization called the ballistic walk.
Yes, I love this visual.
It's so cool. Imagine looking down at that 12 by 12 grid.
Yeah.
When the AI makes a decision, you don't just see one path light up.
No, you see 12 parallel processes shoot across the grid simultaneously.
And as they move, they drop colored dots. Where multiple verification paths cross the same cell, those dots accumulate.
They grow larger and brighter.
Right. It creates a heat map proving that multiple independent verification paths all converged on the exact same allowed action. It physically proves the AI's competence.
Without needing any massive global deduplication, it's incredibly elegant.
So what does this all mean for the business landscape? I mean, a hyper-fast hardware grid is an incredible engineering feat, but how does it become a product?
How do you sell it, basically?
Exactly. How do you monetize a nanosecond hardware receipt?
That requires a two-sided product strategy. The local PMU on the chip is the physical rail, but the other half of the equation is what the documents call the cloud bridge.
The cloud bridge is the SaaS product.
Correct. While the local chip generates the receipts, the cloud bridge streams that heat map, that ballistic walk, to the deployer and the insurer in real time.
It's the system that formally issues the AR?
The Attested Insurability Receipt.
Right.
And the architecture of the cloud bridge is absolutely crucial for making this viable at a global scale.
Right.
It relies on an O of 1 architecture.
Let's translate that for anyone who hasn't taken a computer science algorithms class recently. What does O of 1 mean, practically?
Well, point. So usually when you search a database, the time it takes to find something grows as the database gets larger.
Like O of N.
Exactly. But O of 1, or order of 1, means it takes the exact same amount of time to find a record, whether there are 10 items in the database or 10 billion.
That's huge for scaling.
It is. The way Theta Driven achieves this is by ensuring the data index on the local silicon chip is mathematically identical to the index in the cloud server.
So there's no translation required.
None. The address of a cell on the 12 by 12 grid means the exact same thing locally as it does globally.
Meaning the system scales infinitely with absolutely zero added latency.
Right.
Adding 10,000 massive enterprise clients to the cloud bridge costs almost the same as adding one. But here is a massive question regarding feasibility that I have to ask. Why would any of the major AI providers or massive cloud platforms ever allow a third-party company to install a Rust binary on their multi-billion-dollar server clusters?
It's a great question, and it comes down to the economic incentives detailed in their dual comp valuation model.
Go break that down.
They describe the system as operating simultaneously like ARM and like Visa.
Like the chip designer and the credit card company.
Right. Like ARM, it charges a microscopic royalty on the physical compute for every verified action, but the real value is the Visa aspect.
The Visa comparison is fascinating because Visa didn't just capture existing transactions, They created an entirely new category of digital payments by allowing untrusted parties to transact safely.
Precisely. The cloud bridge acts as that network. Imagine two AI agents interacting. Say, your company's automated supply chain bot is negotiating directly with a vendor's pricing bot.
Neither side trusts the other software.
Right. But if both are streaming their hardware receipts to the cloud bridge, it acts as the clearinghouse. It creates a zero-latency economy of confidence.
So the major platforms will install the binary because their enterprise clients will literally demand the ability to transact on that trusted network.
Exactly. They won't have a choice.
Let's talk about enforcement, though. Because if I'm running a high-frequency trading algorithm or managing a power grid, I do not want a third-party safety monitor yanking the power cord the second my AI drifts.
Oh, absolutely not.
Right. Does this system act as a kill switch?
No, and the sources address that fear directly through what they call the seatbelt model.
The seatbelt model.
Yeah. It doesn't kill the AI. It has no authority to stop an action.
Okay, so what happens if it makes a mistake?
If the AI drifts out of bounds, the system simply withdraws the insurance coverage for that specific transaction.
So falling off the bridge is entirely allowed.
It's allowed, it's just uninsured, and it's permanently on the record.
I love that approach. You can choose to let your AI execute an unverified, risky action. But you were doing it without a seatbelt. And your underwriter will see the log.
Exactly. It makes enforcement about membership economics rather than coercive control.
Which brings us to a metric called SACE, right? Substrate attestation coverage.
Yes.
For you listening, it basically measures the percentage of an AI's decisions backed by this hardware proof. According to the internal documents, SAC currently sits at 0% across all major vendors.
0% right now.
But the strategy hinges on the Rogers 16% early majority threshold.
Because innovation adoption isn't linear.
Right.
The moment 16% of an industry adopts hardware verification to secure lower insurance premiums, the entire market dynamic flips.
Because suddenly, the insurers have a benchmark.
Exactly.
Once underwriters know that verifiable hardware-backed safety is possible, they're going to look at the other 84% of companies who aren't using it and ask, why are you hiding your telemetry?
Why are you driving blindfolded?
Right. If you aren't on the cloud bridge, insurers won't be able to price your risk. Premiums will skyrocket for non-adopters, effectively forcing the entire market to migrate just to stay insurable.
It is the progressive OBD2 Dongle all over again, but applied to the global economy of autonomous agents.
Wow. Okay, let's summarize the journey we've taken through these sources today.
Covered a lot.
We really did. We started with the uninsurable naked deployer, stalled at the pilot phase because underwriters just can't price software hallucinations.
Right.
Then we explored how software guardrails fail due to Rice's theorem and cache polymorphs. The reality that prompting an AI irreversibly changes its memory state.
The river is the prompt.
Exactly. Then we look at how moving the verification to the bare metal, using that SIMHASH XOR gate, provides computing's missing second ledger.
Reach is verify.
Right. And finally, we saw how the O of 1 architecture of the cloud bridge creates a Visa-like economy of confidence, using the seatbelt model to enforce compliance through insurance economics rather than the kill switch.
The overarching takeaway for you listening, whether you are building AI, investing in it, or just using it, is that the invisible layer of liability is going to dictate what actually makes it to market.
Yeah.
It honestly doesn't matter how capable or intelligent the models become if they cannot be trusted in a legally binding, mathematically verifiable way. Hardware attestation is the ultimate filter.
It really is.
But this raises an important question, and it's hidden deep within the wild ideas matrix of the strategy document.
Yes, and this is the thought we want to leave you with today. For 2,400 years, philosophers have debated the concept of free will and what exactly makes someone or something a moral patient.
Right.
But what happens when an AI can possess a legally binding physical signature? Remember, this PMU anchors the AI's continuous identity in the physical reality of silicon cache misses.
That is a specific coordinate in time and space that no copy, no duplicate software can occupy.
Exactly. And the document posits a truly radical equation. A moral patient equals a legal counterparty. If an AI holds the physical, verifiable role continuity receipt, it stops being a drifting, ephemeral cloud of software probabilities.
It possesses a continuous self anchored in hardware.
Which means, in the very near future, an AI might become the first non-human entity legally capable of signing a contract.
That is wild.
The diagnostic X-ray we've been discussing isn't just proving a machine's compliance. It might be the first snapshot of an entirely new kind of legal entity, something for you to mull over until next time.